So it's always good to start a presentation with a question, right? An engaging question. How many of you had a New Year resolution? And also, did we work on it? No. Anyway, for the camera, oh wow, everyone. Okay. Uh, this is my roommate, flatmate, and I. We like a nice good story. We also had a New Year's resolution, and so the previous DMart orders were mostly unhealthy snacks, cold drinks, But in the new year, we decided we'll order something healthy, something which is also good in the budget. But soon later, we found ourselves struggling in a physical market, physical superstore, comparing similar products, similar grocery products, uh, and reading the wrappers for ingredients and prices. But why so? Why going to a convenience store is more convenient than searching it online? Why a search box is not the good window or a decent window to explore all the inventory they already have? Oh, I forgot to skip the slides, but hi, my name is Sourav Ganguly. I am a React Native developer and hopefully someday a cricketer as well. And if you like my talk today, hopefully I give you a reason to follow me. You can follow me on I Sourav Ganguly. I write on most of the platforms as I Sourav Ganguly. On Twitter, I go by I am Sourav Ganguly. Uh, let's give you a reason to stay in contact. How does search work? Anyone? Okay. So when you write a query on your search box, there are typically 5 steps involved into it. And I'll give a quick description of the 5 steps, and these are actually important throughout the presentation. I'll take all of them. So there's tokenization. Whatever user query that we write, it is broken down into words. Now, approximately, let's take one word as a token. Now, there's stemming, where words like running will turn into run, words like jump turns into jump. And we also remove the stop word removals, and then indexing. So a search engine usually has a crawler, right? This crawler will go to every web page or product. It will try to find out what the product is good at. How does it do that? It will search most prominent words included in the description of the product or web page, and then list them down into a table. Whenever a search query is made, it will try to link all the indexes that it has found out, and it would be showing it using ranking, right? Beautiful, right? It's beautiful. And this has been perfect for a long, long time, actually. But here are some issues. I'm here to discuss a few issues around this. And I'm specifically talking about why keyword searching is not such a great idea unless you search with context. And to do this, I'll take help of a word called sugar. And why do I take help of a word sugar? Because it's easier to identify when you see sugar. There's a term. You know it when you see one, right? And there's also market. It's common. It's a common marketing term. For example, sugar free or diabetic, and also a pinch of sugar makes everything better. I just added it. Uh, so for example, this is the first example that I'll show up. I have searched for sugar less biscuits. Now the search query should not have been broken right here. So it basically either searched for sugar and biscuits, but you see the first product that came up. No hates against it, but it's probably not sugar free. So maybe I am wrong. Maybe I don't use phones. Maybe I should know what's the most marketing term. It's sugar free, and I did so. And what the results we have is sugar free because it's in the name of the company. The second one has sugar free in the heading, and the third one is the same biscuit again because possibly they are too good with the category marketing of biscuits. And I'll show one more example where product is good at category marketing of snacks. And when I search for snacks, we have chips, potato chips and banana chips, which is good. And this is a normal common delivery application, 10-minute delivery application, and it actually is very good at context search. But I'll show you an issue. So when you search for midnight snacks, we have 2 products. And maybe people are eating potato chips at night. I eat potato chips at night. It's fine. But it's also the recommendation for morning snacks, where the recommendation could have been cornflakes, oats, fruits, banana, apple. It's also a recommendation for sugary snacks. It should not have been a recommendation for workout snacks, And this is a simple example, and it's funny, supposed to be funny. But what about people? So this was sugar, so you could identify it's a product which has sugar. What about people who are allergic to something, or something they are not recommended to eat, for example gluten or any other substances as such? So we know, sir, the current search engines rely on keyword searching, which is not very relevant. So we as developers somehow believe that the people should that people or our users should know how to phrase a sentence and put it into the search box. Or either do we believe that people should be knowing the most common marketing term? And to make things better, we have also created sorting algorithms and filter algorithms which had 30 more categories to select from. And then we also show 40,000 results. So while searching for it, while searching for the problem, there are many articles that I come across, and there are many problems that I came across. For example, people might have heard it wrong, and when they write it on the search box, they cannot search the product they want. Maybe they have heard it wrong. Maybe they are writing it right just because of the spellings are different. Maybe they are searching for the same product, but because of the country or where they are from, it's just called differently. And even if products are called similar, the marketing terms are different: multifunctional, or all-in-one printers, so and so. So when the user searches for a different term, they are obviously not seeing products which have a SEO of some other term, and they obviously do not see all the products that my inventory or my organization's inventory probably has. So the solution, obviously, natural language processing. We are in an AI meetup, obviously. Natural language processing is the solution. So, okay. Now, just because we don't see a solutions around doesn't mean people have not created it, right? So I went forward to see what are the solutions. So this is mostly how people search for it. There is a service sitting between the client app and the content layer. And this could be any content, the PDFs as well. And this Azure AI search is actually a product. There's also, this was formerly known as Azure Cognitive Search. And how it works is it understands the user's query and find it from maybe an organized set of contents, maybe an unorganized set of contents. I'll show you why this process, when you use GPT or some other tool in between your backend and front end, is not a good idea. But yeah, there are also commercially available tools. I have been exploring Algolia and Azure AI Search. I think these are really good. The others are also AI search algorithms, commercially available with natural language processing and all of that included in it, but they are not very specific for FMCG market. For example, the Salesforce Einstein search is very good at helping their users search from the data using a simple query. Also, there are open source service, search as a service. So when I started, I thought it's a very good business. I'll also create search as a service. But there are open source models which also provide search as a service. There's Elasticsearch, which is famously known, and then Millisearch. So these not specifically would have natural language processing, but it gives a lot of power to already creating a base of search algorithms on which you can create other open source models for natural language and all of that. Additional features they provide apart from natural language processing, I think, sir, you were speaking about personalizing search results, right? So models like this, apart from natural language processing, also personalizes the search results, where it will read the user's history and post behavior and then show the details. And it also has multilingual search at the end. So this exact reason is how problems like these will be solved for multilingual. So you don't have to create SEO. So if you have a product that you have to list on an e-commerce website, you don't specifically write all the possible words and all of synonyms that you have to write in your product description. This will find your product basically for the right user. Okay. So as I said, yeah, I thought this is a great product. This is a great business idea, right? So I wanted to create something similar. I wanted to integrate something like this. But spoiler, I was not successful. So I downloaded different smaller scale models into my local systems to using models that could be run in the cloud. It's a lot. It takes a lot. At the end you have to create a whole new layer that's integrated to the pre-existing layer. And obviously I'm not a AI engineer. I might be. Today I'm not. So, and it's not coding. It's not coding. And that is, if you have used GPT, you would know. If you have used GPT for your applications, you would know it does not answer with the same output every time. So you can ask it to do a certain thing, but it would change the response every time it responds back to you. Yeah, so the model I was working on is, for example, I search for after workout snacks. It goes for is fiber true, is protein true. So obviously it doesn't work. But that doesn't mean the search ends here, right? So I created a prompt to showcase here. So this is how there's a prompt work, and obviously I'm using GPT, Chat GPT, the very basic model every startup owner has to start with. I mean, but yeah, so this is what it is. I'll explain the prompt. Basically I ask it to be a JSON rendering engine, let's say, and then I'll give it a text input, and it has to convert that text input into a JSON format. And doing so, it should be doing it through a certain amount of rules and assumptions, which I'll talk about also, assumptions. But here is the JSON structure it has to follow. There is a product type, brand, price range, uh, dietary preferences, allergens, calories, fat content, and so on. So in the next slide, I'll explain how dietary preferences and allergens work, which is that dietary preferences is actually, I'll not explain the whole JSON, I mean, but these are two arrays. So these will contain elements from a universal set of arrays, which I'll also show. But there are fixed number of enums that will be pushed into fixed number of enums that are supposed to get into allergens, and a fixed number of dietary preferences that will pull from to get into dietary goals, because obviously we don't want the system to be random when we are searching for a certain term or making a query into a database. I do not want that. So if there are any other term that the prompt thinks the user query falls into, or any other prompts that the user has put into the search box, that would be added to the special features, which we can find later. So this is the universal set that I created, which was vegan and all of this. Um, Special focus on gluten free, sugar free, nut free, soy free. I'll show you something which is funny later. But yeah, these are the goals which it has to pick on. Also, there are a list of allergens it has to pick on. Uh, these are fixed number of list of allergens. The product could be filtered on. But yeah, now this is the process. The dietary goal will take atomic elements present in the dietary goals array. Now, a user's input has to be broken down till a point. It can be mapped to one element or any number of atomic elements in the dietary goals array or in the allergens array, or none of the above. It is not allowed to add any more elements or find any more elements that it thinks could fit into the system or JSON. Also, the user's input has to be reevaluated till the map could be found. And this is what I was speaking about, because I provided a data set of arrays. It, I think, kind of used it as a training mechanism, and I suddenly found it out on one of the queries where sugar free is a dietary preference, but it was trying to push cruelty free as a dietary preference. But possibly it's an ethical issue, right? It's not something that will search for as a diet, and it can go under special features. So these things had to be the model should know about. At the end, yeah, here that was the hard part. This is the interesting part, what the results are. So I searched for raw honey and natural sugar, and I did not search. So the user query did not have organic in it, but it did pick up the organic and adds it to dietary goals. And obviously it searches the keyword, the user input that has been uh, sent by the user. Also, for allergen friendly, there's also an interesting output where all the allergens it picks it up, although it has not been specifically mentioned using keywords that it has to pick up a certain allergens. Also, now when you search for a snack that aids in muscle memory, it picks up high protein and searches it against. And again, snack that supports happiness, it searches for protein, low sugar, and antioxidants. Apart from searching for snacks, these will also be filters applied to it. So you don't have to search for and apply filters from the 30 categories that I showed, right? Which were, yeah, I mean, and it specifically goes for low sugar because it has been asked to create dietary goals for people, which is healthy for human body. Hence, now we will not be. Hopefully, this is a solution. I think this could be a solution. Now we possibly not be seeing products which is high in sugar, but are just good with their SEO of happiness and high energy. I hope you liked my presentation. I hope you like me. If you are interested in my talk or Sourav Ganguly, please reach out to Sourav Ganguly on all the platforms. So I also showed you one last thing. I came across this diagram I showed you, but there is a talk by Ekansh. He came up here to speak about how why you should not be using GPT or Chat GPT model directly from your application. So this is a good talk you should go out to, because you are exposing a lot of keys on your app, mobile app, for example, when you are bundling it. So he says your model better be behind the backend or with the backend, right? So that is what I was trying to build when I was trying to download small models, so that it can work alongside with the backend, and not so and not use GPT as the first source after the app reaches, because it's not also good for the security. And anyway, you can go to this talk. It talks a lot about that. Thank you so much. If you have any questions, please reach out to me. Yes.